So in this problem, we are supposed to apply the definition of product of two operators, which I have given here. I've written here from equation 3.3. We need to apply this definition and show that this is equal to this. Okay, so let's actually apply the definition here. In this case, from here, this A can be this, and B can be this C. Okay, if you're going to look at A times B, your A here is a combination of two operators A and B, and your B is C. So that will result in your A times, which is B. In this case, you have C, right? That will result in this. Now, C operating on f of x can be considered as another function, because when an operator operates on a function, you get another function, right? So this is a function, and A, B, the product of A, B is operating on this. So again, based on the definition, you can write it as B of the function, which is this. So we have actually shown it by using the definition of product of operators twice. Now we're going to do a similar proof. This time we're going to prove that this is equal to this. Okay. So again, based on the definition of operators, in this case, we have A as A, but in this case, B is the operator BC, right? So you can write this as A times BC of f of x. So you can write it like that. Now here, when we are looking at BC, you can consider, it's a product of operators again. So you can write it like this. You can use the definition one more time. So in both the cases, we have proven that by using the definition of product of operators twice, we can show the left-hand side of the equation is equal to the right-hand side.